All right, we are starting on experiments. Now, this is probably the most important thing in research design because experiments give us causal claims, which are the things we really want. If we can figure out, what causes something else to change or to happen, well, then we have the opportunity to actually go in and change things, to make life better, to make people happier, to intervene and change, make people less depressed, make them recycle more, get better grades, know how to train your pet or your children. It's just awesome. So we love experiments when we can do them. They take a little bit more effort, a little bit more time, a little bit more money sometimes. But I want you to really get good at identifying the structure of an experiment, how to create an experiment. So we're starting off pretty basic for the beginning of chapter 10. I do want you to read that first, it's like 5 or 6 pages, and then watch the video. I think it'll work better. So anyway, hopefully you've done it. Now, in that chapter, one of the first examples is about theory somebody has in real life, this real guy, about students having this sort of approach to doing their assignments or avoidance of assignments. These sort of 2 styles of, approaching their assignments for class, and one is a better outcome than the other. The students that are avoidant aren't going to do so well. People that approach their assignments with a certain characteristic are going to do better. Now, from his theory, that just gives you a little bit about his theory, it gets to a hypothesis, and it has to do with this color red, right? And so he gives this hypothesis, which he wants to test, and it's if students see the color red, does that trigger some kind of avoidant behavior, and they don't do as well? Now, this is just one little tiny thing that if it's consistent with this theory, he expects a certain outcome. And one of the first things I want to drive into your brains is, what is a hypothesis? A lot of times in high school or even other classes, you may hear a teacher tell you, oh, a hypothesis is an educated guess. I hate that. I don't want you ever to talk about hypothesis as an educated guess because there's no guesswork involved. I think it's very misleading. What I do want you to think of it is a hypothesis is a specific prediction. It's a very well thought out and purposeful prediction. If my theory works the way I think it does, then if I go out and manipulate the color that somebody sees when they're about to do some problems, I'm going to have an impact that will change how well they do on those problems. It's a very specific prediction. I have lots of good reasons I want to predict it. So there's no guesswork involved. So please get rid of that educated guessing. Now, let me tell you the cool thing about experiments in science. Hypotheses are predictions. We are stating up front what's going to happen at the end of our study. Now, in some respect, you might go, aren't you just going to find what you're looking for? Doesn't that introduce bias? Well, it can, but that's why we have a lot of things that go into how we design studies. So we have to design our studies to prevent bias. Okay, so that's a big job. But here's the thing, if we don't make the prediction, we're not doing science, because have you taken social psychology? You may have, or intro psych, you may have remembered the confirmation bias or the hindsight bias. That's the better one. Hindsight bias is, something happens, you get your end result, and you go, oh yeah, well, of course, that makes sense. I knew that was going to happen all along. Okay, well, we can say that for anything. If I just ran a study and I go, I don't know what's going to happen, and I get my results and I go, oh, well, that makes sense. I could have seen that coming. I knew it all along. We could, once the data are in, we can make up any story that would fit the data and make the data make sense. But science doesn't work that way. We actually have to make our prediction up front. We have to say, before I even collect the data, this is what I expect. This is my specific prediction. It's based on my theory. If my theory works the way I think it does, this is what's going to happen. So I say it first, I design my study, I collect my data, and it worked. Hey, I predicted the future. I told you exactly what was going to happen. That's pretty cool. Now it's just one study. Maybe I got lucky. Maybe it was just a fluke. So I'll run it again. Maybe I'll change a little bit. I'll use a different population or change how I manipulate a variable just a bit, but still testing sort of the same thing, my specific prediction. Run my study, get my results. Ooh, 2 for 2, looking good. Okay, so I keep doing this. And every time I'm right, every time my specific prediction is supported by the data, my confidence is growing in my theory. It's like, I don't really know what I'm doing, don't I? Well, I mean, anybody can, say they were right after the fact, but not everyone's going to be able to say up front, here's what's going to happen. And then time after time after time, it does. Now, if it doesn't work out, well, then you have to ask, first of all, you ask, well, did I screw up my study? Maybe I didn't design it well enough. But maybe I did and my prediction is wrong. That's possible too. So you keep going with other experiments and eventually you figure it out, what's going on. All right. Turn off cell phone. No cell phones in class, people. All right. So moving on to our hypothesis. Now I want to run an experiment. I have the specific thing in your book. It's about a color. If they see the color red as opposed to something else like green or black, I think it's going to affect their performance on this task I gave them, the number of problems they're going to do. So every experiment has the same basic structure. You have your independent variable, which is the thing that's going to be manipulated. Experiments have at least one manipulated variable. That's the thing that the researcher is in control of. They're going to randomly assign their participants to some group of the independent variable. Now, these are our groups, let's say. Now, if I'm the one for the, in the textbook with red, it had 3 levels of the independent variable. So if the IV was, we'll put 3 up here, was color that the people saw their student number in, it had like red, green, and black. Okay, so the IV, again, it's the thing that's manipulated, the researcher manipulates. I'm going to sample my participants and then randomly assign them to one of these 3 groups. The dependent variable is the one that comes later. It is the measured variable, right? So the DV is measured. So IV manipulated and the DV is measured. And it comes later. So what the DV is depends on which group you were in. Now the different groups of the independent variable can be called levels, comparison groups, anything, but I'll say levels or groups or something. So you saw a test booklet with red, green, or black, your number printed in red, green, or black, and then I measured later your test score. And guess what? The red students who saw their number in red had a lower test score. Now, for experiments to work, here's the key thing. First, by randomly assigning my people to my 3 groups, what I'm doing is I'm creating basically 3 equal groups, as equal as I can make them. Okay, just random people put in. There's nothing different about these people. Well, there are, but their differences are just kind of spread out evenly. We'll talk about that a bit. So they start off just kind of saying these 3 things. Now, I treat them exactly the same. Right? They probably take this test in the same room. Everything about the test book is identical. The problems they're solving are identical. The only thing that should be different is your independent variable. The only thing that is different is what color their number, the student number was. So when I then later measure their test scores, and my statistics tell me these test scores are significantly different, such that the red group has a lower score. And I go, why could that be? My only answer, if I designed a good study, is, well, the only thing that was different was the color of their number. It must be that. That's exactly what experiment tells me. I hold everything else the same. Therefore, it has to be the color of the number. So everything I hold the same is a controlled variable. I'm controlling for context. So I got IVs, I manipulate it, I tell you randomly what you're going to get. Then I measure the dependent variable from everyone. So we got a manipulated and a measured variable. And then we have controlled variables, things I want to make sure are the same. So the only thing that's reasonably different about these groups is the color they saw, my IV. Okay. Let's give just a quick couple more examples. Let's say I'm interested in, we had an article on driving and cell phones. So they put everybody in a driving simulator. They have the same course that they're driving, right? It looks the same program. But they're doing one of 2 tasks. Either they're driving while talking on the phone, holding it, or they're driving with a hands-free thing, okay? And then I measured the number of errors. And didn't they have a 3rd group where they're just driving, some kind of baseline. And you see you have more errors when you're driving compared to just driving in the simulator with no phone. You got more errors if you're using hands-free, and even more errors if you're holding your cell and talking, or they had to text. Anyway, everything else would have been the same except your task. You know, were you texting, or were you hands-free, or were you just controlled? Let's see, so the independent variable was the task, the dependent variable was the errors you made while in the driving simulator. What if I took students and I had them come in to take a test, but they were randomly assigned to instructions, and one group was told, wear professional dress. You know, if you're a man, have a suit and tie, women should have a suit, you know, skirt or pants, whatever, but professional dress. And the other group was randomly assigned to say, hey, dress as comfortable as you can be, sweatpants, whatever, just, you know, no dress code, just be really, really comfortable. What do you wear on the weekends when you're sitting on the couch? They come in, they both take the same test, and I look at their score. And I find those who were dressed professionally score higher than those who were dressed, you know, really casual and comfortably. So IB would be the what you were told to wear, and it was professional was one level, or another group would have been casual, so 2 levels. And then the dependent variable, what was measured, your test score. Let's say we have kids and I have them do a little problem set. There's an example in your book like this. They solve some problems, and one group of kids is randomly assigned where the person says, hey, you did great, you must be really smart. And another group of kids was said, hey, you did really good, you must have worked hard. So they got a different kind of praise. Either they were told it was something about them or something that they did. Now they were given another set of problems, and my dependent variable is how many problems do they attempt on the second round? And I find those who were praised for, like, it must be something about you, you're smart, actually didn't try as hard as those who were praised for working hard, for the process of what they did, not that it's a personality thing. So the IB that manipulated what I randomly assigned the children to what kind of praise to get. The dependent variable was measured later, always comes later in time, so that's one way to try and keep them straight. And it's the same, they have the same problems that they're doing, and I'm just counting how many did you attempt. Okay. Let me see what else I want to say just now, because I want you to go and study it. Oh, something about those controlled variables. So not everything has to be identical. The variables you control have to be things that make sense. So yeah, if I'm giving you problems to solve, or an exam, or you're driving a course in a driving simulator, that's going to be the same in all groups. That's important. I wouldn't want to give people different amounts of praise and then have them take different, you know, tests or do different problems. They have to be the same, right? In your book, it talks about, like, the pasta example. They did an experiment where people were served pasta in a big bowl or a medium bowl. Well, they have to keep the pasta the same because they're measuring the dependent variable for that one was how much did they take. Well, one was like this really awesome macaroni and cheese, and one was just like these dry noodles or something. That's going to be why they took different amounts. You want to hold things that are important constant. Now, there's lots of other things that might not be as important. I don't have to get data from every person in my experiment on Tuesday at 10 a.m. because probably what I'm studying does not matter. A lot of things, the time of day may not matter. The day of the week would probably not matter for most things. So far, everything I thought about wouldn't matter. Now, let's think about the pasta study from your chapter. Yes, I would have to serve the same pasta to both groups. So we had a large serving bowl and a medium serving bowl. That was the independent variable. You're randomly assigned to one of those. And then we measure how much did they take when they served themselves. So you would definitely want to control for things like, you know, what pasta was served, whether or not they ate immediately from coming to the lab. So when they sign up, you might give them instructions, please don't eat for 1 hour before you come to the lab. That would be kind of important because, you know, people have eaten a lot. Maybe the instructions or the behavior of the people. You don't want to go, hey, pasta, everybody, here's a big bowl, take a lot. And then in the medium go, well, we just had a little bit, here you go. Well, that could skew your results. You want things that matter, things that might affect how much they take to be the same between the two groups, because the only thing you want to be different is the size of the bowl, if that's what you're testing. All right. Notice the random assignment. We're going to talk a little bit more of that in the next part of this video series, but they're mentioning how they talked about doing random assignment. They talked about rolling a die for which group you'd be in for the color study, pasta. What did they do? They flipped a coin for which group you're going to be in. those were random procedures used to decide, okay, I've sampled you and I assigned you up, but now what group are you going to be in? And we'll talk a little bit more about that. I think right now what I want you to do is go take the IVDV quiz, which is in the assignments and quiz folder, and practice. There's like 3 scenarios, and you got to find the IV, the DV, some controlled variables, how many levels of the IV. Just go practice that, and then you'll be ready to go on with the next part of this experiment video series. All right.